Hello friends, good evening. Welcome to Math Made Easy, your companion for understanding math with ease. So here I am sharing a video on basic concepts of maths while we'll keep syllabus in core. So video will have concepts and example based sessions, and today I will start with 8th standard, basically the state board. So we'll focus on first chapter, which is rational numbers, and we'll try to understand what rational numbers are and how you will define it and how it will be represented on number line. So first, all the natural numbers. So natural numbers that starts from 1 2 3 and onwards. Whole numbers. Whole numbers start from 0 onwards, 1 2 3, and then we have learned about integers, and integers includes the negative numbers. So you get minus infinity to say -2 -1 0, and then 1 2 3 and goes on. And then on continuation to this, we have what is known as rational numbers. So now, what do you mean by rational number? Any number in the form of numerator by denominator first, and then denominator should not be equal to 0. So this is the important condition to qualify the number as a rational number. So it can be represented as n upon m, or p upon q, or x upon y, any one of them. Only the condition fulfilling would be m or q or y should not be equal to 0. So this is important condition to qualify any number as a rational number. So if you have -1 upon 6, this is a rational number. If you have say 0 is a rational number. But if you have 1 upon 0, no, this is not a rational number. 8 upon 7, rational number. 9 upon 3, rational number. 6, rational number. And likewise, you can go on writing what are the example. Only important condition is denominator should not be equal to 0. Okay. So let us now try to plot the rational number onto a number line. So we have plot the numbers like whole number, natural number, integers in number line, but rational number, how you will plot on number line. Okay, so you know this number line 0 1 2 3, and of course I am writing it roughly. You have to use a proper scale, so your number line should be scaled properly. So here you know where 1 is, where 2 is, where -1 is, and where -3 is. Accordingly, I can locate any number in the number line. I can locate any natural number, whole number, or integer. But to locate a rational number, the same number line can be used. Only thing you have to see what is there in your denominator of a rational number. Suppose your rational number is say 1 upon 6. That means you have to see the denominator, and you have to divide the number between 0 and 1 into 6 parts. So equally again. So 1 first part, second part, third part, fourth part, fifth part, and sixth part. So 1 2 3 4 5 and 6. So now your number is divided into 6 equal parts. So now this will be termed as 1 upon 6, 2 upon 6, 3 upon 6, 4 upon 6, 5 upon 6, and then this 6 upon 6, which is nothing but 1. So now where 1 upon 6 is located, it is over here. So 1 upon 6 is here. So likewise, you can locate like say 8 upon 6 in the rational number, or in the your number line as 7 upon 6, 8 upon 6. So you can locate it over here. And likewise, you can have your different number lines for different rational numbers. Suppose 3 upon 2. if you have to locate this onto a rational number, onto a number line. So 0, 1, 2, and now as you are saying, it's 2 parts, so 1, 2, 2 parts. This is 1 upon 2, just this is 1 upon 2, this is 2 upon 2, nothing but 1, and this is 3 upon 2. This will be 4 upon 2, which is nothing but 2. So 3 upon 2 is over here, your number, rational number 3 upon 2. Likewise, if we have to locate minus 3 upon 2, similarly minus 1, minus 2. So minus 1 upon 2, minus 2 upon 2 is nothing but minus 1. And then here you will have your minus 3 upon 2. So likewise, you can locate your rational number in number line, and you can use any rational number to locate your number line. So that's very simple and very straightforward. Now we will try to compare the rational numbers. Okay, so in comparison, there are two methods. Today we will learn the basic method or easier method. So you have two rational numbers, say 2 upon 3 and say 1 upon 7. So which rational number is bigger or greater? So first thing to compare the rational number is you have to equate the denominator. So denominator should be equal. Okay, now how you will do this? To equate a denominator, it is important to know one more concept, that if you multiply the rational number with any integer, the value of rational number won't change. Okay, so for example, if you have 2 upon 3, if you multiply it by say 3 in numerator and denominator, then the value of rational number will be equal to 2 upon 3. So 6 upon 9 is nothing but 2 upon 3, same. So if you multiply in the numerator and denominator with any integer, the value remains same. So now how you will equate this over here denominator? So to equate the denominator, you have to consider the denominator and you have to consider the least common factor of this. So for both of them, the least common factor would be, of course, over here 21. So what you can do, you can multiply 2 upon 3 by 7. So you get 14 upon 21, and you can multiply 1 upon 7 by 3, you get 3 upon 21. So naturally now your denominators are equal. So you can represent 2 upon 3 as 14 upon 21. You can represent 1 upon 7 as 3 upon 21. Now, once your denominator are equal, you have to compare the numerator, which numerator is greater, that is 14 upon 21, 14 is greater, and therefore your rational number 2 upon 3 is greater than 1 upon 7. A very simple and straightforward method whereby you have to equate the denominator and compare the rational numbers. So now there is another method. Suppose you have A upon B and C upon D. Okay, so here how will you do the comparison over here? Okay, so sometimes it's you have to just look upon the number and see which is greater and which is smaller, just by looking, and do not do this lot of math. So you can cross multiply these numbers, A into D and B into C. Okay, so once you cross multiply, you will get some value. So let us apply this over here. In this example, you cross multiply, so 14 and 3, and here what you are seeing, that 14 is greater. So straight away here also you can apply this rule, that if your A upon D is greater, then the rational number on the left hand side would be greater. If your B upon C is greater, then the rational number on the left hand side would be greater. Naturally, let us take one more example, like say 6 upon 7 and 1 upon 8. Okay, 6 8s are 48, 7 1s are 7. This is greater, so your rational number 6 upon 7 has to be greater than 1 upon 8. Simple, straightforward. So that's all for today. today's session on rational number. We have tried to understand what rational number is. Important criteria is denominator should not be equal to 0. Second, we tried to locate the rational number on number lines, and it's quite simple, straightforward. And third, we compared the rational numbers by first equating the denominator and second by cross multiplication method. So that's all for today. I will join